All right, hi everyone. In this video, we're going to discuss how we can subset an array in R. And the way that we subset an array in R is much the same way that we subset matrices earlier in this module. So it's nice. We don't need to learn a whole bunch of new stuff. We're just going to extend our prior knowledge over and see how it applies in this new context. So we're going to use indices much like we did with matrices. So we're going to indicate which row and column and slice we want to keep inside a set of square brackets. So now, rather than indicate two indices, a row and a column, I have a row and a column, and I'll call it, for the third dimension, a slice index as well. So we've got three values that we can indicate. So let's illustrate how subsetting works with a concrete example. So let's consider an array A that we're going to define in this first code cell over here. So here we're going to arrange the integers from 1 to 24 into a three-dimensional array. Each of our slices is going to be a 3x2 matrix, and then we're going to have four of those slices joined together to make our three-dimensional array. And this is the same array that we had created in the previous example. So we'll use this as our motivating example for slicing. And I'm just going to write these out on the screen so I don't have to keep scrolling up and down. Okay, so I just have my array A that is being displayed in blue on the right side here, which is this 3x2x4 array. So here I just want to be able to display this array along with the code and the output rather than have to scroll up and down every time to see the original array A printed above. Okay, so we index and subset arrays just like we do matrices. So I'm going to put a set of square brackets next to the name of the array. Our array was named A. And now I just have three indices to indicate as opposed to two when we had a matrix. So I've got a row index, I've got a column index, and a third dimension. I'll just call this like a slice index. So if I run this command here, this is going to select the first row from each of these arrays. So it's going to select the values 1 and 4 from the first array. It's going to select the values 7 and 10, from the first slice. It's going to extract 7 and 10, the two values in the first row of slice 2, 13 and 6, 19 and 22. The question is, how does it arrange these values? And if you remember, with matrices, when you subset one row of a matrix or one column of a matrix, it dropped the data structure and it returned a vector back. It returned the one-dimensional thing back. And we'll see something similar here. When I run this code cell, it's not going to return a three-dimensional array back. It's going to give me a two-dimensional array. It's going to give me a matrix back because I'm selecting the first row of each of these slices. So I'm going to run this command, and notice I have this output inside of a print command so that I can see the data structure of the output. So what I got here is a matrix, first of all. So I have a two-dimensional array. So I dropped a dimension in this process. And now I have a two-dimensional array or a matrix as my output. And here is how things were aligned. It took this first two values, it aligns it in down the columns, right? Which is the default for how matrices are set up. So here, I'll just draw this out. What this subset is going to do is we've got a matrix over here. So it picks these first two values, 1, 4, but it places it down a column. And then it says the next two values were 7 and 10. And it's going to place those down a column, and then 13 and 16. And then the last two values were 19 and 22. So what is left over is a matrix now that has 2 rows and it has 4 columns. So it dropped that first dimension from it. And now as a result, what it kept was an array that has the same dimensions as the last 2 dimensions of the array that we started with. So this array that we started with over here, this was a 3 by 2 by 4 array. So when we subset the entire first row, it drops this dimension and is going to create a matrix or a 2-dimensional array, which is 2 by 4. So that's how it arranged those values. So it took all of these values from the first row and it arranges it into a 2 by 4 matrix over here by filling things in down each of the columns. Okay, so let's take a look at what happens next if instead of subsetting the first row from every slice, we're going to subset the column 2 from each of our slices. Okay, so if we were to subset array A that we are working with, the same array A, but now we're going to subset it so that we pick off column 2 from every slice. Now what's going to happen, it's going to work similar to the previous one. We're going to drop this middle dimension now. So what's going to be left over should be something that's going to have 2 dimensions because we lose one of the dimensions, and we get the dimensions of the resulting array by looking at the size of the 2 dimensions that we kept. So we kept 3 and we kept 4. So we're going to get a 3 by 4 matrix in the end. And what are the values that we're going to arrange in that matrix are going to be the second column from each of these slices. So for each of these slices, we're going to go ahead and take the values in the second column. And then we're going to arrange them into an array that has 3 rows and 4 columns. So let's take a look at the output. And notice again, it fills in the matrix going down the columns by default. So what we got is the first values are filled in until that first column is complete. That first column has 3 values. So that's where the 4, 5, 6 comes in, and then the 10, 11, and 12, and so on. So this gives us altogether this matrix over here. So this came from slice 1, this came from slice 2, slice 3, and slice 4. And then we join all of those together. So that's how we subset an array. And notice that if I subset an entire row or an entire column or one slice out of the array, then the object that's created is going to be 2-dimensional. It has 1 dimension less than what we started with. And let me clear out some of this. So I just want to show what would happen over here if I don't include the print command and I just have pick off column 2 of array A, then it printed it out in terms of a matrix over here. So it didn't look too horrible. It looks more or less the same as what we started with. But that print command will help include the indices for the rows and the columns around the edge. And the last thing I want to just mention is, let me get rid of all this stuff, is that if I want to keep the structure, so, right, we talked about how we could use this drop argument with matrices so that when we picked off an entire row or an entire column, rather than store it as a 1-dimensional vector, it was able to keep it as a 2-dimensional matrix. So I can do the same thing here. which is inside of this index, I'm going to add the option drop equals false. And if I run this command, this did it differently, right? At least we're seeing the output is being stored as a different data structure. It's being stored as a three-dimensional array still. So it's going to keep all of the same dimensions as what we started with when we put the drop equals false argument. The default is that it sets drop equals true. So we actually get a two-dimensional thing back as opposed to a three-dimensional array back. I'll run this again without that drop command and without that extra comma to get back the matrix that we had before. We can also enter vectors as indices when we're subsetting. So in this next code cell, I am going to subset array A by keeping all of the rows and columns, but keeping only slices 2 and 3. So keeping these middle two slices. So if I run this code cell over here, what we can see is we are getting an array, a three-dimensional array as the output. So when we keep multiple values in one of the indices, right, the structure of the result that we get back can be different dimensions. So when we subsetted just like one row or one column or one slice, the result is a two-dimensional array, which is a matrix. When we subset multiple rows or multiple columns or multiple slices, what we get back is a three-dimensional array with the same dimensions as the array that we started with. So this just pulled off slice 2 and slice 3. And the result again is an array that is 3 by 2 by 4 that has the same dimensions. In this next code cell, here what we're doing is let me hide the output here. We are going to subset the first row and the first column of A. So that is going to pull off this value is in row 1, column 1, this value, and this value. So what we're doing is we are picking off something that's going to be a 1 by 1, since in each of these things, I'm only keeping one value here, one value here, one value here, one value here, but we do this for each of the 4 slices. So how this is working when we're getting output that is not the same dimension as the array that we started with, it's just when we have one of these dimensions as 1, it just decides that it's going to collapse it. So in this case, the first dimension is size 1, the second dimension is size 1. So it says we don't need those dimensions. And all that's going to be kept in this case is going to be a vector that has 4 things. So I'll run this and we'll check the output is a vector of 1, 7, 13, and 19. And this is a vector, just a one-dimensional thing that has 4 elements in it. And if we want to keep the same structure as the original array that we started with, again, we can use this drop equals false command, and this will subset the same 4 values. The one that we see over here, we have the 13 that we see over here. I skipped over the 7 and the 19. So this has the same values. It's just storing it in a 3-dimensional array. So that's the big difference there. And the last type of subsetting I want to talk about is if we want to extract, say, a group of individual elements from the array. So let's say, for example, I want to take the element in 1, 1, 1, which is this one over here, and 3, 2, 4. So this means I come over to slice 4 and look at row 3 and column 2. So that would be this value over here. So let's say I want to extract the value 1, and the value 24 from this array. And I know their positions of these two values that I want to slice out. I can do the same thing as I did with matrices, and that is I can construct a matrix where each row has the indices of the value I want to extract. So this first row is 111 because it's telling me the location of the first value. And the second row is 324, and that's telling me this location. And then I can use this matrix of values as to help index this array. So the first thing we're going to do is create this, and this is what we're going to call V in this case. So this is going to be some matrix V, and that's what this first code cell is doing over here. So I'll run this, and we can see this is creating that matrix V. It created this matrix using the column bind function. So the first column is 1, 3, the second is 1, 2, and the third column is 1, 4. I could have created this using rbind as well. But the important thing is here I've got my matrix V. It has 2 rows, and each of those rows is giving me the location of each of the 2 values I want to extract from this array. And then I would just index on V. And so if I do A and then in square brackets V, it's going to pull off one value corresponding to the first row. It's going to pull off a second value corresponding to the second row. And I could have additional rows and pull off more values. But this is just going to pull off 2 values, 1 and 24, and store it in a vector. And just like with indexing in other things, we can use the minus syntax to exclude certain rows or certain columns. Okay, so that's a wrap on arrays. We'll next take a look at lists, how we can create lists and subset lists, etc.